Hello, this is Brian Hagelstrom, working with Excel, and in this case here, exponential regression. I have some data over here related to the half-life of carbon-14, where every 5,700 years, we're going to see the amount of carbon-14 decrease by half each time. We want to make a prediction for when the age of a relic here that has only 20% of its carbon-14 remaining. That's going to be between 11,400 and 17,100 years of age. But let's try to narrow it down by using an exponential equation. Going here and highlighting my data, I can go insert, and I'm going to create myself a scatter plot. I do like moving the chart as its own sheet. This way I've got a little larger graph to work with here. I'm going to provide a chart title that this is carbon 14 dating. And then since I'm not seeing the plus sign, I'm going to come up here to add chart element, look for axes titles, and make sure I get titles on both these axes. Going with this one here, what we have is the percent of carbon 14 remaining. And then down here is the age of the relic. And now we got ourselves a nice scatter plot. I'm going to look at one of these data points, do what's called a right click. Go with add trendline. This case here, we want to choose the exponential and make sure you do display equation to display our squared value. Keep in mind these forward and backward forecasts. Sometimes these might be nice, especially if you know you're making a prediction that's further into the future or maybe backwards in time. I do have my equation here. I'm going to kind of go ahead and move it and increase the font. There we go. Oh, that's not looking too useful. Looks like I got scientific notation there. Might be nice to round off a little differently. So I'm going to make sure this is highlighted. I'm going to do another right click here. It's actually, I think, a little better doing it this way here. Make sure formatting takes, where we're going to go kind of to one of these little circles here where we see the tread line, do a right click, and we're going to format the tread line label. We're going to change this to number. And I want a lot more decimal places than what I'm seeing here. Let's actually go 8. Let's overshoot it big time here, so that I'm actually getting a little better number to work with here. Notice that with exponential regression in Excel, you will always have it written in terms of base E. So you'll have to know how to work with E a little bit if you're going to use this equation to be able to make predictions. Otherwise, you're going to have to use your TI graphic calculator to get a little different equation as opposed to the one that you're seeing here. What we're going to do is that we're going to let our y value be 20 for 20%, and then go ahead and solve for x, which is the time. If you go ahead and do that, what you're going to get for this problem here is that the fossil is going to be about, let's see if I can look up what I have, about 13,235 years. Well, that's actually a little bit too precise. Carbon-14, that's only one problem in the book. The book really wants you to estimate to the nearest year. Carbon-14 is not that accurate. Maybe it might be best to just say around 13,200 years of age, give or take a few hundred years. Let me go ahead and go insert. We're going to go ahead and do shapes. Get my box going here and create a box to be able to write in here. So if 20% of the carbon 14 remains in a relic, I'm going to assume it is about 13,200 years old, give or take a few hundred years. It's not precise. That's one problem with the book here. Us mathematicians, we like being precise all the time. In reality, carbon-14 is just a very rough approximation. Here's our prediction. Maybe kind of increase the font here a little bit. We won't talk about interpolation or extrapolation for this example, though you should be willing to do so for your problem, though. Make sure you mention that, and that if it is extrapolation, make sure you're mentioning there's some risk involved in terms of the estimate. In some ways here, this will always be kind of an extrapolation in some regards with what we're doing here with this type of dating, especially since it's very rough approximation anyway. So there's always going to be some risk involved with this, and there's a lot of things that can affect carbon-14 dating as well. Another thing I could do maybe as well is go ahead and get a little arrow and maybe point out in the graph where that 20% is in my prediction, just kind of get it together here, right there. And then people can kind of get a visual image as well that it is just slightly over 13,000 years old. So now we got a professional looking graph, we got an equation that can be used, and we can continue to make other predictions with carbon-14 dating. This is Brian Hagelstrom working with Excel and the Add Trendline feature to be able to do exponential regression.